If you have been wondering why are we spending so much time on factoring, you're about to find out. We're spending all this time on factoring because it can help us solve problems. We're going to use factoring and the principle of zero products. For just a moment, let's remember what that is. The zero product property. Now you've had a little time while I was writing that to think about what it is. If I have anything, let's say 57, and I multiply it by 0, what will my product be? 0. So if I have A times B equals 0, what can I say about A and B? I can say that A may equal 0 or B may equal 0. The zero product property, you look to have 0 on one side of your equation, and then you look at what you've got for products. And what's going to happen now, we're going to use factoring in order to create products where none exist on the left-hand side of the equation. So a little practice here in factoring expressions. How would we factor this? We know it's going to be x and x. What else do we know? Since this is negative and this is positive, we know we must have two negatives. That's the only way when you multiply them together you get a positive. What else do we know? We need two factors of 6 that when we multiply, when we add them together, they give us -5. So that would be -3 and -2. How about this one? Now, up here we didn't have to worry about a monomial, although if I'd been wise, I would have mentioned it, because that would be one of the first things we always should think about. This one actually does have a monomial we can pull out. Both of these terms can be factored evenly by 2 and by x. So let's do that. Factoring, of course, is merely dividing something out of the terms and setting it up as a product. So I'm going to divide this by 2x. That will leave me with x. I'm going to divide this by 2x. It's going to leave me with 2. On this one, I can see that I do have a common monomial. Whenever you see that you've got all even numbers, you know the least you could do would be to factor out a 2. That would leave us with 4x squared minus 12x plus 9. Now the other thing you might notice here is that this is a square. 2x squared will equal 4x squared, and 3 squared will equal 9. This should give you some suspicion that you may have a perfect square trinomial. How are you going to test this? You take the square root of this, which is 2x, the square root of this, which is 3, and you double it, because it will happen twice. And if it turns out to be 12x, then you know you have a perfect square trinomial. So this will factor further. We already factored out the monomial, but even after you've done that, you ask yourself, could I go further with this? The answer is yes. So we've got the 2, then we've got 2x and 3 in a binomial squared. Remember, a perfect square trinomial always factors into a binomial square. We take the first term from the first term of our trinomial, the square root of that, our second term from the last term of our trinomial, square root, and we take our sign from the middle. So there it is, factored. We've done 3 of them. Let's do the 4th one, and then we'll move on into equations. Solve this one. We're actually going to do an equation right now. If I divide both sides of this by 3, in order to simplify, I will have x minus 5 equals 0. If I add 5 to both sides, I get x equals 5. That is my answer. Solving equations by factoring. So we're going to keep in mind, we're going to be using the 0, product, property, I've got the 0 right there, but I don't have the product. If I can factor this, I will have a product. X, X. This one looks pretty darn familiar. We didn't have to spend any time. We know what it factors into because we just did it. I have the 0. I have the product. Now I can say this factor may be equal to 0. X minus 2 equals 0. Or this factor may be equal to 0. So I set up the factors as little mini equations and solve those. That will give me the solutions for the original equation. So x is equal to 2, or x is equal to 3. How about this one? A difference of squares, right? This is a perfect square. 2x, if I square it, will give me 4x squared. And this is a perfect square as well. When I have no middle term, that tells me I'd have to use conjugates, wouldn't I? The only way you get rid of that middle term is to have a plus and a minus. So it's going to be 2x as your first term, square root of this, and 3 as your second. One's going to be positive, the other's going to be negative. These are conjugates, and when you multiply them together, they give you a difference of squares. So if you have a difference of squares going in the other direction, you can factor into conjugates. I'm going to set each of these factors equal to 0. So I have my 0 and I have my product, each of those factors. 2x plus 3 equals 0. 2x minus 3 equals 0. When I solve, I'm going to try to isolate my x term, so I'm going to subtract 3 from both sides. 2x equals negative 3. 2x equals 3. X equals negative 3 divided by 2. X equals 3 divided by 2. There are my two solutions. By the way, whenever we have a polynomial equation with a factor, an exponent of 2, we expect to have two solutions. Our largest term is second order, x to the second power, we expect to have two solutions. Let's look at this one. Oh my goodness, can I hopefully divide this through by 3? Let's see. I don't know. Will 3 go evenly into 105? Oh, thank goodness it does, because I didn't like the looks of those big numbers. I'll still have big enough numbers. Yes, it goes in evenly. So we can say, we're going to factor out a monomial, x squared minus 12x plus 35 equals 0. Now my challenge is to find two binomials that when I would multiply them together would give me this trinomial. I know it's going to be x and x. I also know this has got to be minus and minus. How do I know that? This is negative and this is positive. The only way this can be positive is if both of these binomials have the same sign in the center. Okay, I see what it is. Do you? 7 and 5. Negative 5 times negative 7 gives me 35. Minus 5x plus minus 7x gives me minus 12x. So I divide everything through by 3 on both sides, and I end up with x minus 5, x minus 7, those two binomials, the product of those equals 0. So I have 0 and I have a product. I'm all ready to solve this. X minus 5, one factor, equal to 0, and x minus 7, the other factor, equal to 0, for x equal to 5 or 7. What are the solutions of this? Now, sometimes people, because we've been looking at so many binomials, they forget that x is itself a legitimate factor here. So we say x equals 0, that's one factor set equal to 0, and x minus 1 equals 0. This one, of course, we have to do a little more work with. So there we have two solutions. How many solutions will this have? Well, we're going to divide the constant out of here to simplify it a little bit. That makes it more evident to us, doesn't it? By the way, we never divide out our variable, never. But a constant, of course, we can divide that out. So this would have two solutions, and what are they? You can probably tell me without even having to set up those mini equations. -1 from this factor, and a +1 from the other factor. Now, it didn't actually ask me what the solutions were, so I should be careful that I answer the question that was asked. How many solutions does this equation have? The answer is 2. Okay, so you're going to do some more of these in the classroom, solving equations by factoring.